I essentially want to create one type of the tray, or one instance of the type tray for each entry of the lookup table, right? To actually build. And I can do that programmatically. All you have to realize is that it's a good old-fashioned inductive definition, not unlike factorial, right? Because if you can do it for 255, you can do it 254, 253, 252, and it's an induction, right? It's the same idea. I can do that to actually build my graph. So let's take a look. The first thing to do is I want to make a special type family. Exactly like I had the type family for factorial, I'm going to make a type family called vector. And vector correspond to vectors of scalars. For example, 0 is a vector. 0, 1 is a vector. 0, 1, 2 is a vector. 0, 1, 2, 3 is a vector. 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way to 255 is a vector. Right? They are all vectors. I want to code all of them up as types. So all these guys, I vectors, are vectors. They're also types. And inside the type, you have the sequence of indices that correspond to the vector. Okay? Creating one of this is very easy, right? You can write I vector 0, 1, 2, 3, and then you're done. I want to do that programmatically though, so that if I ask, produce me a vector that has all the integer between 0 and 65,000, I write one line, it automatically generates all of them. Right? The vector with all the values in it. Okay? So I want to do that completely programmatically. Here is how I'm going to do that. Nothing should really shock you. It's a fairly short definition. I'm creating I vector as a struct. Yes, it's a type. Okay? Now, inside of this time I don't put a value, I add a type. Now we're going to look at what that type is, but before that, we need to look at the stanza above, which you have already seen. The argument to my I vector type is a parameter pack, which is a collection of integers. IS is a list of integers. Now, if that's what I get when I write int dot 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 is, the dot 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 before tells me this is a definition of a parameter pack. Is represent a sequence of integers. What I'm doing here is I say that the type that's embedded inside I vector is I vector itself, but this time I'm taking my parameter pack and I'm expanding it. Remember that parameter pack expansion takes every parameter in the pack and comma separates them. So what I find when I write this, if my parameter pack is 0, 1, 2, 3, I get the parameter pack, the sequence 0, 1, 2, 3 embedded in here. So the type and I vector itself are one and the same. An I vector 0, 1, 2, 3 has one type embedded in it, which is just a pointer to himself. Right? So it's a type that's self-referential. But inside of it, there is a sequence of value. I still would have to create it by hand, right? I would have to write I vector 0, 1, 2, 3 to create one of them. It's just that if I want to get the vector with the first 65,000 values, it's a lot of typing. I don't want to do that. I want to generate it programmatically. But creating one is easy. That's all you got to do. And notice here that no loop, no nothing, right? It's just a family of type. And I'm creating one specific member of the family. Okay? And this guy only has inside one type. So that's easy. Now I'm going to actually generate them automatically. And for that, I'm going to use another type. Because I'm computing at compile time, so I'm computing with type. That type is called iota. If you look under CPP reference, you will see that in the algorithm package, there is a function iota, which is a higher order function. This function is just supposed to generate a sequence of integers. If I say iota 255, it will generate a list of values 0 to 255. Therefore, what I'm doing here with this iota, which is now a type, is that I'm doing the same as the iota function that's part of the C++ library, but I'm doing it at compile time. The iota function will take one argument, an integer. Now you see, I'm saying the iota function, even though iota is a structure, iota is a type. But I'm seeing it as a function. Why? Because the template argument is like the argument of the type, so it's like the argument of the function. Iota, the function, would take an argument. Iota, the type, takes an argument, which is an integer. So I'm going to call it with something like iota 255 or iota 256. Okay? Now there is a second type here that takes a default value, and the default value is an I vector with an empty parameter pack. It's an I vector that has no value in the list. So the second argument, the second type, passed to the iota type, is a type that represents the empty sequence. First argument is an integer, second is a type which contains the empty sequence of integers. Okay? And here notice it's like defining the prototype. Right? I'm just giving the header of the function. I haven't done anything yet. So far so good? You're completely clear on the signature? You can read it? Okay, good. Now, one more step. Focus on the first two lines. Notice first that I'm defining struct iota again, but this time I'm giving you the implementation of the iota family. Iota has again two arguments. The first one is a size, the second is a parameter pack containing integers, and it's called IS. IS is a sequence of integers. So this one has a sequence of integer. And what iota does, when he receives the size and a vector containing the parameter pack, is that this guy inherits from iota on size -1. That's exactly what you told me earlier. I'm making one type inherit from another type. So by saying that iota 255 inherits from iota 254, it forces the creation of iota 254. And iota 254, who is he? I'm going to use the same type family, so I will need iota 253, then iota 252, then iota 251. So you will generate, C++ will generate the 256 iota types. Each one of them will contain something. And notice that they all inherit from each other. Iota 256 inherits from iota 255, which inherits from iota 253, right? It's the column of inheritance. This struct inherits from that struct. So they all inherit linearly, all the way back. Now, that's for the first argument. So far, so good? You're good on that, right? Now, what about the second? I'm receiving a vector with a parameter pack, which is a sequence of value. And what I'm saying is that, yeah, well, when I'm calling, instantiating the next type in the hierarchy, it's going to contain an I vector with I size -1, and then I take my parameter pack and I extend it. Which means that whatever parameter pack you gave me, I'm going to stick in front another value. So if I start with iota 256, iota 256 inherits from iota 255, and it contains an I vector that starts with iota 255, and whatever parameter pack you gave me. Now, if I started with the empty parameter pack, it's 255 followed by the empty parameter pack. Now, you know what's going to happen. The call to iota 255 inherits from iota 254, which uses an I vector with 254, and then the parameter pack received expanded. But what is that parameter pack? Well, it's the parameter pack that starts with 255 and has the empty parameter pack behind. So now I've stuck 254 in front of 255. And I keep going automatically. Now, when does this stop? Like factorial, when you hit the base case of the induction. Yes, it's recursive, right? So this last stanza is iota 0, just like factorial before. That's the base case of my induction. I still receive a parameter pack. Iota 0 receives an I vector, and it inherits directly from I vector, and I extend my parameter pack. I'm done. What have I achieved here? I've achieved something very simple. If I say iota 10 will inherit from iota 9, from iota 8, from iota 7, from iota 6, all the way to iota 0, and iota 0 is an I vector And the I vector, we've seen it here, it has inside of it a type which is I vector with the parameter pack. So therefore it has the type I vector 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Done. I programmatically create an arbitrary member of the I vector family by using the iota template. Point in case, this is what's happening, right? 256 is that. When you do 256 and iterate from 255, it takes 255 and it sticks the input pack behind. Then 255 inherits from 254 and it sticks 254 in front, etc. all the way down here. So I vector 0, I vector 0. I've completed my inheritance chain.
What's the syntax for accessing?
We're going to see that. You can guess it, actually. It would be a good exercise. To access it, it's like you want to have the nth value in the vector. How would you get the nth value of a list? You answer your own question. How would you get the nth value of a list in a classic functional format?
You grab the tail.
Yes. Yes. So you write a function, get tail, which is a function, but here it's going to become what? Struct, a type. It will become a type, therefore struct. So you will have struct get nth element, which will have as an argument the index, and it will do instantiate the next type with n minus 1, and it do that until you hit the base case, which is n is 0, at which point you return the value at that position in the sequence. In the map. Because you shave a value. Remember the parameter pack, you can always shave a value in front, right? So that's how you do it. That's how you get to the nth entry. Good exercise. Great questions for homework. It's beautiful.
Hypothetically, it's in your code you called iota 256, and then later on you also called iota 257. Is it smart enough to stop before the base case?
Detail of the implementation of the compiler. I don't care, right? Because the compiler, I run it once. All I care about is that it creates the correct type with the correct value in them. Whether it needs to evaluate it twice or once, it's a matter of how the compiler is implemented. So remember, at the end of the day, I'm doing this to create a data structure that I embed in my code, right? So the runtime of the compiler is immaterial to me. But, you know, smart compilers try and do it only once. I agree. But that's really a compiler implementation issue. We're good? You see this? So now you see that I have this hierarchy of types, of iota types, and the very root of the hierarchy is actually the I vector type with the parameter pack I care about. I can actually show you that, right? Now I have, again, a static assert that use std is same, which is a meta-programming predicate, that check whether two types are identical. For example, here I'm asking iota 4. There is a type inside of that, yes. Iota 4 inherits from iota 3, from iota 2, from iota 1, iota 0. Iota 0 is an I vector that contains the sequence 0, 1, 2, 3, right? So I'm checking whether the I vector 0, 1, 2, 3 type is the same as the iota 4 type. If that is true, then this will evaluate to true, and the static assert will say everything is hunky-dory. Okay? So this is just the static assert, is just to debug and test that my iota function is correct.
So I might be a little confused, but is this just for creating an array of like natural numbers with zeros?
Yes.
Oh, okay.
That's
So
what it
and
is.
we're gonna change this in a minute.
Now we're going to use this. We're going to use this to really hit our target, right? All I'm doing right now is generating a sequence of values, an arbitrary sequence of values of arbitrary length, and embedded that in a type. So that I'm going to write now another function that takes that as an input, and I'm saying another function. Remember that the function, when I'm meta-programming, is a type. I'm going to write another type that uses this type that has a sequence in it to produce the LUT. Right? But I need, because the LUT is indexed by these integers. So I'm creating the list of indices that are used to index my LUT. Then I'm going to do the LUT with them. Because I'm going to use something really, really cool. Are we good? Those are good questions, right? It's not obvious that I'm taking my time. There's a reason. We're good? Awesome. Now I'm home. That's it. That's the full implementation of this. Remember that I'm defining first a type, LRGB table. So this is again the prototype. It's a brand new type. It's a struct, LRGB table. And it's templated by something called indexes, plural. It's all the indices. Now I'm going to say, let's implement that type. The type implementation of LRGB table, it's templated by a parameter pack of integers. It's going to get me a bunch of integers. And what it contains is an I vector of IS, right? So that's my list of integers. Now, what I find inside that type, this time, it is not an integer. It is a function, a C++ function called at that receives an integer I, and what does it evaluate to? A const static float, an N3. And what does it contain inside? It contains a const float lot, and here I'm using LRGB trait is : value ... curly brace. What is going on? Think about it. ... behind the name. What is that? What do we call this when we see 3 dots behind the name? Knowing that you have seen this and that. What is IS? It's a parameter pack. When I actually put ... behind the name, and within that name there is the parameter pack, what am I doing? I think I heard it. An expansion of the parameter pack. Remember, if you write just IS ... you take every value of the parameter pack and you comma separate them. But here, it's not just IS ... it's this big thing. So when it's that big thing, it means for every value in the parameter pack, create the big thing, put a comma, and do the next one. So I'm getting LRGB trait 0, value, comma, LRGB trait 1, value, comma, LRGB trait 2, value, comma. I'm getting all of them for every value that's in the parameter pack. Therefore, I'm expanding this, and this is what? It is the initializer of an array. So I'm expanding. For every parameter pack, I am mapping. Using the type trait, I'm mapping the index to the value of the lot. This is the map higher order of scheme done in C++ via metaprogramming. I told you this thing is Turing complete. You can do anything you want. I'm doing higher order in the compiler. Right? And I'm expanding the whole thing. Now that I have the lot, since I was writing a function, if you ask me for index I just say lot I. I'm returning the ith entry. Notice that because this is const x, is going to do the parameter pack expansion at compile time. So this array will exist inside that function, which is itself const x. If it was fed a constant, it would be evaluated at compile time. Now notice that the name is a bit ugly, right? The name is here. This is how you call the function. That's a mouthful. LRGB table, iota256 type at I. I have to type that each time? No, that's crazy. So I write another convenience function. LRGB, fasten int, and it calls that. That function is, of course, const x, so that it can be inline and disappear, which means at the end of the day, all of this stuff boils down to one assembly instruction.
Is that just like a member function of that structure? Or
Yeah. Yeah, it's a member, it's a method. But remember, right? It's const x static. It's a class method. You don't need to have an instance to call it. Because if you don't put the static, every word matters here. If you remove static, then it's a method that must be invoked on an instance. But here we don't have an instance, we only have a type, and we're doing this at compile time. So it's static as a method. Which is okay to do that. Because we're at compile time. You see what's going on? So I'll be with you next. I'm really exploiting my parameter pack expansion together with the type trait to start generating all of them. showing that in my array declaration. Because the function is static context, it will be created at compile time, so the LUT is created at compile time. I would have to type that every single time I want to do a lookup in the whole thing. I find that ugly, so I wrap it up in a function with a better looking name that I call LRGB. And therefore, even that, because I inline it like that, it's going to be eliminated, and I will have just an array lookup. We are going to look at the assembly to convince you of my time. That's the story. Question, Brandon.
Do you need the app member function at all?
I've tried about for 2 hours to get rid of it because I didn't like it, and I can't. Because you cannot have a template with an array. I cannot have an attribute which is static, const, and be an array, but I can have a static method. So again, it's an idiosyncrasy of context business, right? It's not as cute as I'd like it to be because I have to put that function, but anyway, it's in line. So it's a little more typing, but it's in line at the end of the day, so it doesn't hurt my performance. Make sense? So that gives you, we have like 15 minutes left. So I plan to actually show you a little bit, show you the assembly, convince you that this works, right? And then answer your question, because I suspect that you will have questions, even if they're not popping up right now, because we've covered quite a few things, right? We've seen context, we've reviewed computing with types, I've shown you types that are embedding scalars, I've shown you types that are embedding sequences, now I've shown you types that are embedding method that embeds data structures. It's quite a bit to go over and to really appreciate why they were doing hierarchies, why the methods are static. Oh, everything matters, right? Drop pretty much every single keyword in there. It stops working, right? Everything is, that's why metaprogramming, I usually leave it out, but you seem to be strong enough for me to cover. So I've done it this time around, but this is advanced stuff already in C++, metaprogramming. It's not that obvious, right? Probably people start writing metaprograms when they have like 5 years experience. So this shows you what it's truly capable of in a real setting. But to gain the ability to do this on your own, you will need a little longer. You'll have a homework anyway.
So is most of the time when we're trying to do like a lookup table, at compile time, we're gonna have to like pattern match this kind of.
Yeah.
Okay. And it's almost always the same sort of.
Almost always the same. It's an induction, and you've seen. I mean, I like it was Joe's question. I think, how do you index? Who asked the indexing? So the indexing itself, think of it, how you write it, think that types are functional. Right? So if you want it to write indexing, you'd be in a functional, you'd have a list. It would be an inductive definition, it would be recursive. And therefore, every function becomes a type. You see, iota was a function. Check iota in the C++ standard. You will see that it matches that. It's a function, it has arguments. That's the same story here. The functions become types. And you have to do that mental exercise of jumping from your algorithm that you would express with a function, expressing it with types. Then all the higher order are pack expansion. Mapping is just a pack expansion. It would be cool to try and see how do you implement filter, right? So you're giving me so many good ideas for the exam. Yes, Oliver.
So
I'm teasing.
So it looks here like you told us we couldn't have arrays. Suddenly I guess you meant we can't have an array that is itself a const expert.
And it is nested inside this.
Yeah. Okay.
Right? It's nested inside the type. That's the trick. Is that this thing is nested in the static method inside the type. So that's why in that case you can actually do that. You can't. Again, I completely agree. This would be far more elegant if I could write const x static float bracket and write my array like that and just tell him like do it with a for loop and be done. That'd be great. Just the language doesn't support. My whole point was to show you in C++ metaprogramming how far can you go. Factorial only gave you a hint of the taste. This gives you a mouthful, right? It goes a lot further in terms of demonstrating what can be done in C++. And it's a metaprogramming, and I thought that the gaming example was a beautiful application for what people are doing in other languages. Here you can do it in C++. Compiler is out there, it's been capable of doing that for a few years. And so this exists, right? People use that. All right, good. So let me show you. I think we're done at this stage with everything. Yeah, so it's callable, beautiful, we're done, demo. And that's for the end, right? So we're done. That was the last lecture on C++. But first, let me go back. No, where do I have that? Over there. All right, so S2 LRGB, MP. So this is the program, right? Notice my context for the root, context for real linear. And here we go. My trait, my type tray is here for evaluating one entry of the lot, okay? Nothing tricky. Then with a static assert to verify that this works. Then my definition for a vector, purely its signature, what a vector type looks like, and it embeds the sequence of value. It doesn't create a vector. For that, I need iota. The next step is the type definition of iota, the prototype in a sense, and then the iota definition, inductive, base case. This is a recursive definition, right? It's a recursive type. It's a completely recursive definition. And you see that it's using inheritance, and all the way down, I'm inheriting from the last one. Static assert to test that my code is working at compile time. Then I create the prototype of the table itself. Here is my table definition with at that contains my lot with the parameter pack expansion here and the value. I return the lot, convenience function LRGB, and here I'm still spitting out so that we can actually run the program and see whether it has worked. But to convince you that this is indeed working, the only way is to go and find the definition of the lot as a table in the assembly. Okay, we got to do that. All right? So let's suspend C++, S2 LRGB MP, dash std C++ 14, dash S, emit LLVM, minus O bar.ll. It's done, ground. Let's load bar.ll. Okay, main. Not very interesting. Here's the printf, and that's it. There is nothing else. Okay, so this is a tiny little program, okay? There is nothing much going on. Is it the right one? I compiled the right file, right? Bar LL, yes, I compiled the right. So there is an LRGB lot here, and you see all the floats? That's my table, pre-computed. Now, I mean, clap for the compiler. I did nothing, right? I just learned to use metaprogramming. But the table is here. That's 255 of them. Imagine all the typing you have to do by hand. Imagine if you ask for a bigger one, right? And this is your main function. And because everything is tagged const x, so I could play the same game as we did last time. For example, not tagging this guy const x. At least I would see the function at in my code if I'm calling it, right? Which is normally the case because here I'm calling LRGB inside the loop, right? So let's just remove that, recompile and see what happens. Foreground, bar.ll, reload, and here we go. You have LRGB, the function, and guess what? Call LRGB vector with the index. So you see it here, right? The function is there with that crazy name because that's C++ name mangling. It's a crazy name, but the function is there, and it's actually indexing. Now, here is the function definition, right? You see the long name, you see the name, right? LRGB table. Then the argument is an I vector, and then, whoops, sorry, I vector, and then you find the value 0, 1, 2, 3, right? These are the entries of the I vector. You can read that, right? The thing in between says like, yeah, it's a long integer, the argument. Okay, so you find the name of all the types of all the arguments inside. Then the argument to the function is an integer, and it uses a 2-byte alignment. Now, what is inside that function? How does it work? Oh, look at that. Get element PTR. For those of you who already took compiler and used LLVM, well, you know that this is array indexing. It's indexing an array of 256 float, and it's using the index, which is argument %4, which is the argument we've received, and then we load that. So that's it. It's a get element PTR and a load. One, because the load is the assembly instruction, right? The get element PTR is just the offset computation. So if I was to generate Intel assembly, you would see that this function add, if I tag it as a leaf function, has one instruction in it. Yes?
Will it still show the table somewhere in this assembly?
It's up there because here you see the get. The name of the table, it's a global variable at zzn9. That's my table. zzn9. You see it? Here's the table. It's up there. You can always look at the assembly, right? That's why it's great to take a compiler class. You can actually look at that stuff. Joe.
This is a little bit of a pivot, but another type of metaprogramming I've seen is kind of trying to do a reflection on data structures. So like a motivating example would be to try to like print out a debug for a struct, but you don't want to like manually change the debug function for every field.
True. That's another use of metaprogramming. So what's your question about it?
How would we approach that in this?
Carefully. I think it's a little bit beyond what we can do here. Not at least with the remaining 4 hours of class time. I could have 2 lectures with this, but I wouldn't even do it justice. It's pretty big, but yes, you can do that. The thing is that C++ does not expose, in terms of introspection, C++ exposes very little about its representation. So even in the metaprogramming, you won't have access to everything. Check the CPP reference. You will see std is same. It's a metaprogramming for that. It checks whether 2 types are the same. Remember that you do everything with types. So debug information would get embedded in types. And you would use these metaprogramming criteria to check whether types are identical, whether they match the signature you expect. To do branching on switches, you would do it that way. But this is heavy. This is heavy stuff. But browse CPP reference. I still don't know all of it. I don't know 100%. I know it can be done, and I know it's a big thing, and it's probably too ambitious for 2 lectures. But yes, it's one of the things you can do with method. Yes.
Just to sort of add on to that a little bit, there's this idea with like C++ 20, there's other called like meta classes, which is exactly the same. And so it's like the information allows you to reflect on types and do a lot of things. So if you are interested in that, check it out.
So, I mean, new standards, remember, C++ every 3 years, there is a new version of the standard. I will have to update this very soon to switch to 17, because 17 has become official a few months ago. C++ 20 is in the draft state, right? We have a few more years before it matures, and they agree. Remember, they had wonderful proposal for C++ 17. They pared it down to a smaller subset that they could agree on. Right? So each time they have this big agenda, and then things shrink. Then there's the core that they agree on, and that's what makes it into the official standard. They're at the drafting stage for 20, and yes, indeed, I forgot that 20 people did that. They have things for metaprogramming specifically related to debugging. But yeah, there's stuff you can do today already, but it will be better over there. What will make it in the standard, I don't know. But it's good. If you want to really program in C++ for a living, you should stay on top of the draft of the standard to know what's coming, because very often they implement these things in debug or experimental mode in compilers so that people can really get the feed before it becomes official and give feedback to the standard committee. Right? This is how these things evolve. That's why it's such a slow process. Yes?
So who's defining the standard? You may have said at some point.
It's a committee. Strauss-Trup is still on it, but he has this agreement with member of the committee. It's a little more brutal sometimes. But it's an IEEE standard. So IEEE is behind this. A bunch of guys, some like me, some from industry, who just duke it over for deciding, no, that's a terrible idea. This is clever. So it took them a long time to agree on closures, for example, numbers, right? Standardization is a complex process. It's really complex. There is as much politics as there is science in it, and it's sometimes who's the loudest who wins, not necessarily what's the best possible. And there are things that, I deplore, right? I found it out. It's not like I think that everything is great. I think that they made mistakes. Right? The way that they handle these types of closures, to me, horrendous. They could have done so much better. Can't stay. In case of it, could have done this a little better. But we live with what we have. At least it's technology working today. All right, that's it. So we've covered everything. You can't go yet. You have 48 hours extension for your homework. You do a good job.
I don't think anyone's doing it.
Huh?
I don't think anyone's doing it.
Oh, it's a bad idea. That's pretty good idea. Do it. The next homework will be out in 2 days, right? And it will be, guess about what? Meta program. That's the last one, right? I forgot to vote by the department today. Okay, I'd like to have you back here for 5 minutes next Monday morning. For one reason. It's purely an administrative thing. It's nothing important, but I want you to see. The university, you know about SET, right? Okay, so first, SET, you gotta do it. Not only for this class, but for all your classes. Give feedback. The university cares about it, and it's giving people aggravation if the sets are bad. It's giving people aggravation if the response rate is low. So do yourself and your fellow students who might take these classes in the future a favor by offering feedback. Be fair, be constructive about feedback. Please do it. But the university thinks that the official set is not enough, and they have actually asked departments to supplement the set with another set of their own making. So the department has decided to do that. I should have brought the forms today, but I came straight here and I didn't pick them up. But that's why I want to have you back here. It's another style of set, which is a form that you would do in line. I would pick a volunteer, boom, Brandon, you're in front of me, too bad, it's you, to actually distribute these paper forms so that you can actually, it's bubble sheets, so that you can fill them up, collect and bring them back to the department. I need you to do this for the class. Same story, right? Take this seriously. That is meant to complement the normal set. The department wants us to do it. I realize that it's 2 set evaluations now. Not my choice, but I gotta live with it. So you have to. So we do that. So please come back. I think like if you need 5-10 minutes, you would do that in class. So it's okay if it's at 11 for me, or 5-10 minutes to 11. Yes. Yeah, I mean, but everybody should come in at 10 to 11, for example, right? Then you sit down, you do that. Brandon collects it, brings them back to the department. It's anonymous, right? All of that stuff is anonymous. But you really, 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 really have to do it. Right? I insist on that. And what I will tell that I told to people before is that I monitor my response rate on the set. How many people filled in the set, the official one. And when I don't see that percentage go up, I get depressed. And when I get depressed, what do?
Code templates.
Huh?
Program.
I write exam questions. Always. If I get depressed, I write exam questions. So please don't get me depressed, right? Just all I need to see is the response rate going up, right? Now I want you to be honest and give the feedback you deserve, but do it. Yes.
I mean, I just want to say I always do it, but I always do it like last day, so I have the most amount of information. I've seen a lot of other people about lately.
Yeah, but it's stressful. And it's stressful, and if I write questions and then I don't get to use them, it's depressing. So I go from stress to depressed. So it's not good either. So, I mean, you have all the information about the class, right? The course is essentially over at this stage. You have everything. I will look up, so remember, you have a voice for deciding what format the exam takes. I decide today. Right now, it's a close race between the 2 options. So the take-home is winning, right? but it's close, right? A few more people cast the ballot the other way, you can change your mind as well. A few more people cast the ballot the other way, the outcome changes. So which points right now is that I cannot make everybody happy. Half of the class will be pissed, no matter what. So, moral of the story, you've taught me something. Don't give you a choice. It's a bad idea to give you a choice. That's cool, I can live with that. I won't do that anymore, it was a bad idea. But still, now that you have the choice, exercise your freedom of speech, use that choice, pick, vote. I will go with the majority, simple majority. Okay? Yes.
But if you just do 2 exams, and
No. That is even worse in terms of fairness. No, I won't do 2 exams.
Then it should be roughly.
No, I
One
won't
out
do
of
that.
class, one out of class.
Not
That's a regular
2
exam,
exams.
but
No. I know Christmas, but it was 6 months ago. No, not doing it. Yes.
Is there any value in trying to convince you, or is it just you're going to do the results of the survey?
No, I mean, I presented this. I want to actually, I wrote a post saying what I find good and dangerous about both options. There are advantages to you and there are inconvenience or there are risk to you as well. And Brandon puts it effectively. I mean, he's been in 3100. I was pissed last semester with the amount of cheating that went on. And several people got Fs last semester because of that. Just, I can't stand it, but it happens. People try to sneak through. That's the risk. With a take-home, that's the risk. And it's a risk I'm willing to take because I hope that you heard me loud and clear. The stakes are high. Play with me and you will regret it if I catch you. And I think I have a few tricks up my sleeve for catching you. Right? I know. I have done my homework as well. So that's the risk. The advantage is that there is no time pressure. But there is a little more to do, right? Because you have, I can't expect you to do in 48 hours what is doable in 15 minutes. Come on.
If it does happen to be take home, would there be a written portion associated with it, or just like a single problem?
No, it's going to be exactly like, the same thing that you had in class, a little longer to fill in the time. And then you submit, everything goes into Git. So you might have to write some text file with your answer so that you don't manipulate paper. That's it. Yeah. Pretty conventional, but as I said, what I said in my post in terms of duration.
You may have mentioned this on the technical board, but what would be the 48-hour period if you decided that if it was a take-home?
I'd like to have it before to separate it from your exam year. So it wouldn't be during the exam, it would be in the next 2 weeks. Right, we have 2 weeks left officially.
So a lot of seniors in this class, and a lot of senior classes do exams on the final week before exam week.
Also, this thing called senior design.
Right.
That too. April 27th.
Yeah,
So
okay.
it
So
might
not
be
April
much easier
27th.
on
Your message is not April 27th.
For sure.
April 28th is
not
okay.
right before it. So
April 28th.
we're going to be fortunate.
This is just after one day.
The conclusion is giving you options. It's giving you a headache. So I don't want to give. So I will be sensitive to when SDP is taken, right? But the point is that it would offload from your exam week period and reduce contention that might happen over there, even if it's on the Friday of that week that we're scheduled. So fine, the last day. So it's also the last day of the exam period. It would be. I would have if I give you 48 hours. I think it's putting 48 hours in the exam week is nonsense. I would do that before. And reason. Honestly, by now you know your stuff or you don't. To be totally fair, I think that your potential for passing or failing does not depend on the format of the exam.
Well, I have an argument against that. I believe that people who've been coding C++ for longer or have had experience before this class are much faster, especially getting the reinforcement of this class as opposed to learning through this class. Therefore, being restricted by a 2-hour time limit could be extremely difficult for the people who are new to C++, like myself.
No, I agree with all of this. I agree, right? I offered the option for a reason, because I believe that some people would benefit from having time pressure taken, right? I completely understand that, I heard the argument multiple times, so I put the option on the table. Now, that doesn't change my belief deep down that if you know how to code and you've learned the stuff over the course of the semester, you should be able to take the exam this afternoon. Okay, next week. But you should be able to take this without much stress. You should be able to fly through, and yes, the grades of people are going to move a little bit, but remember, I curved this, right? And it's okay. I sometimes have passed people with fairly low grades. So this is elastic, and everybody, that's why I'm absolutely against pick your own poison option, right? It's like everybody has the in class, or everybody has the take home. Nothing between, because that is unfair. Right? Yeah, everybody, if it's short and under time pressure, everybody is under the same time pressure. Even the people who are good, they won't have time to double check themselves. They will have to go and think on their feet really fast. Everybody should be the same. Now, clearly, if I give you 48 hours, I'm doing this so that Savannah and myself stop crying when grading. Right? Because with 48 hours, I expect much better result. Don't submit after 48 hours something that does not even compile. I will have no pity whatsoever. You can't get something to compile after 48 hours? Come on. Think this is a job interview and think what will happen. Right? After 48 hours, the thing has to be right. Then I will judge on the elegance and the quality. But not compiling, it's a guaranteed zero. Right? Whereas I can be a lot more forgiving when you have to apply, because I understand you have only 2. Make sense? You all understand where I'm coming from, right? But it's your choice. I will check tonight, right? End of the day, I look at this, and then you'll hear the news on the news group as to what is your fate. All right? Good. 11:10. Let's go. Have fun. Don't forget, 10 to 11 next week, right? I will remind you.
Recommendation for the asset-based database paradigm you were talking about last week?
Not on top of my head. I have to look it up.
Okay.
I can find something. Send me an email so that I don't forget.
Okay.
So you'll make a post on the page tomorrow or something?
Yeah, or later tonight or tomorrow or something like that.
Yeah.
All right? Off. There we go, off.
A few things. Thanks
Would
for.
you-
I'm sorry. You can go ahead.
Would you consider a review session where people can ask
Yeah, I
questions
can do a review session. Yeah, of course, I can do
I would
that.
really enjoy.
I can do that. It's no problem with this. I mean, not this week, right? It's too early, but I mean, early next week, something like that.
And
This room, that's kind of annoying.
I can come back in a few minutes.
No, it's fine. No worries.
Is it all right if I